So we are doing the overriding the equals. So the equals is coming in from the top level object, and then we are overriding it. But we have to define what the equality means to us for our objects. As usual, if I am using equal, it's going to be checking the object reference. Remember, each object is going to have its reference, its address in the memory. That's going to come back to it. So the variable of an object contains the address of the object in the memory. That's all it does. So be aware of that. So if I do equal, it's just checking to see if they have the same address. So the content of my variables is just going to be the address, and it's checking to see if they are the same. Most of the time, that's not what I want to do. I want to see if they are equal. So I'm going to be defining what's the equality for the class that I'm writing. In this case, we have a stamp. So when I say equal, one stamp is equal to the other one, what is it that I am checking? So I, as a developer, with my requirement document, and if I'm not clear, I'm going to go back to my customer and I'm going to ask them, what does equal means to you? Does it mean they have same color? Does it mean they have same picture? Does it mean they are the same size? Does it mean they have same values? Or it can be multiple of them. So when I find that out, then I'm going to be writing it into my equal function. Then from this point on, when somebody is using the equals of my object, that's what they're going to be comparing. So in this case, we are checking for the value and the color. If the value, I think that's what you're checking. So if the value and the colors are the same, then they are same, returns true for the equals. Otherwise, it's going to return false. In this case, I have two of them pointing to the same location. This is the way that we're going to be checking for equal to see if they are looking at the same location. So we're going to overwrite the equals that's coming in from the top level. So remember, when we are doing the overriding, we have to use the same signature of the method. And the signature for this method of equals is this. So it's going to have a public, it's going to have a Boolean, it's going to have the word equals, and it's going to be a type object. Remember that we can pass subclasses instead of superclass. What is that called? The ability of passing a subclass instead of superclass in a method like this. What is that called? Come on, guys, you got to know this in your heart. This is going to come up every interview for object-oriented programming.
Is it polymorphism?
Polymorphism, correct. So polymorphism, you got to know this. It's going to show up. So you all failed your interview except Brian. Okay, so I have to have the same one because my top level is object, is using the object. That means what? When I'm using this equal to, so if I need the price, or if I need the color, or I need a picture, or I need a size, I have to have methods of type stamp. So the object doesn't have those things. So I have to typecast it to stamp to be able to execute those methods that's specific to stamp.
Professor, I got a quick question for
Sure.
override. So basically, in my IDE, whenever I try to override a method, I get a line that autofills, and it says add override. So is that just like basic commenting from the IDE, or should I take
Well,
it out?
that's giving you some more tools to help you out. So first is try to fill it up for you. Second is going to put a comment for you that's override. So when you're creating your Java doc, it's going to say that this method is overriding another method that's coming in from the superclass.
Okay, thank you.
Which one are you using?
IntelliJ.
Yeah, they provide you a lot more. Sometimes I don't like that because it takes my thinking away from me, but most of the time it's very helpful because it just tells me what I'm supposed to do.
Yeah,
and remember,
sometimes it actually autofills the typecasting too. So
yeah, it just, well, it has benefits mostly, and sometimes just take that thinking away from me. But the good thing about this is we have to be careful that this signature has to be exactly the way it's supposed to be. Otherwise, it's going to be overloading, not overriding. And that's not going to be good. Be sure you know the difference.
right.
Any other questions?
No, that was it. Thank you.
Okay, so because I need the color and I need the value, and the color and value are not part of the object, if I don't typecast it to stamp, then it's going to say, I don't know what the color is, what the value is. Remember, if the super comes in, the super object doesn't have color or value. Even if it's another objects coming in, they don't have color and value. But if I typecast it to a stamp, my stamp object has the color and value. Another thing that happens over here with the equals, I have direct access to my instance variable, even though they are private. So even though they are private, in my equals method, I have direct access to instance variables. All right, so that's for that one. So the instance of is going to tell me what type is it. So sometimes when I want to be a little more precise, before I typecast it, I'm going to check it to be sure that's the type that I want, because there is a possibility that somebody might send another object to me, to this method. So as far as is the type that I want it, I'm going to typecast it, I'm going to do it. But if it's not the type that I wanted, so I am asking for a stamp object and somebody send me a car object. And if I try to typecast a car to a stamp, I'm going to have all kind of issues. So I'm going to check it to be sure that the object is the type that I want. And then I'm going to typecast it. I'm going to do whatever I need to do. Okay, so we're going to, okay, what do I have here? Okay, I want to talk about these abstract things, and then we're going to take a break, and then we jump into chapter 10. We're a little behind, but we're going to be okay. Okay, so what we learned in chapter 9 was you have a class, a superclass, and then you're going to create a subclass for it. We learn about overriding methods. So if I have a method in a superclass, we are going to be overriding it to use it in subclass. Now, when I am responsible for the superclass, in some instances, I don't know how to write a method. And or I want to be sure whoever who creates a subclass from my super is going to be writing this method. Example, we have had shapes. If I want to know, if I want to have a method to create an area of a shape or draw a shape, I don't know what that is till I have the shape. So the area of triangle or area of rectangular or area of a circle, they have different ways of doing it. But in the top level, in my super, I don't have no idea how to write the area. But on the other side of it is, I want to be sure that everybody who create a subclass of a shape is going to have a method called area. Or I want everybody who creates a subclass of a shape would have a draw that's going to draw that shape for me. So drawing a circle would be different than drawing a rectangular. It's going to be different than the triangle. So at the top level, I'm going to say I'm going to have a method of draw or a method of get area, but I cannot do it till the sub one does it. So two things happen. One, at the level of the super, I don't know how to write the method. Second, I want to be sure that everybody who's creating a sub is not going to forget to override this method. So if I don't force it, some people would write it, some people would not write it, but I want to be sure that they're all doing it. So abstract methods are the methods that I don't have the detail of it, or there is not a good default for the superclass, or only the subclass programmer can know how to implement. Okay, so the example here, it says, okay, I have a bank that we're going to be saying we're going to have every account type must have some kind of a monthly fee. But I don't know if this monthly fee is going to be, for the checking is going to be different, and the saving is going to be different, than retirement account is going to be different in different ones. So I don't know what it is, but I want to be sure that everybody's going to have that method. So I'm going to have a method that's called deduct fees. This deduct fee in my superclass does not have any implementation. So if I declare it like this, some people would override it and create it, and some people may not do it because they forget about it, or they're not thinking about it, or they don't pay attention to it. So what we're going to be doing is we're going to define it as a abstract. So we're talking about the method. My method is abstract. That means if you create a subclass of a class that has this method, then if you don't overwrite this method, it's going to complain about it. You cannot move on till you write the implementation of this method. So you have seen this with some basic GUI that we did before. Now, when we have that, and then you are going to be writing your code, then you are forced to do your now you are forced to override that method in the subclass. Now you cannot have an abstract method in a regular class. You have to have abstract method in an abstract class. So you need to have abstract class to put your abstract method in it. So in Java, you must declare all abstract classes with the reserved word abstract. So we're going to have an abstract class that's going to have abstract methods. And now when we are going to have a class that's going to extend this one, then they have to override this method. That means they have to give me the implementation. They might leave it empty. You're going to see it when we do more of a GUI stuff. So they have to have this method. If they don't want to write the code for it, fine. But they have to have this method. So I'm gonna create a class abstract. Inside of that abstract, I'm gonna have a method that's abstract. Then I'm gonna have, okay, the things about the abstract. You cannot make an object of this. You cannot have an object of a, I guess I'm getting so many messages today. When I turn my phone back, it should have stopped. Okay, so I cannot construct an object for the abstract class. So I cannot say new in it. I can have object reference. So I can have an address, but I cannot have an object. So how is that gonna work for me? So if I have a saving account that extends the account, inside of this saving account, I'm going to have the method that was abstract. It doesn't let me to move on till I have this method and its implementation. Now I can have a type of account, which is my abstract class, and I can create something in here. Okay, when you pay attention to this, I have an abstract type. I am not creating an object. I'm creating a reference. So right now, this reference is pointing to nowhere. It doesn't have anything in it. It's a null pointer. That's the data type of this one. I cannot create a new account. I cannot create an object of my abstract class. But if I create a new saving account, I can put the reference of my saving account into my reference of abstract. You're going to need this somewhere when you're creating the method. I don't think we're going to do it in this class, but you're going to know this is available and you're going to visit it later. And of course, we can set it to null or things in that matter. Okay. So when you declare abstract, you are forcing whoever is going to create a subclass to have that method. All right, so that was for the abstract. Now I'm going to move on to a final method and classes. So the abstract job was what? To force developers who are creating a subclass to make the implementation. Now the opposite of that is I'm going to have some method or even some classes that I don't want people to do anything with it. I don't want them to touch it. I want them to use it the way it is. I want to be sure nobody can override this method. So I have a method that I don't want anybody to be able to do override. So in that case, I'm going to call it as a final. So I can do it for my method. I can do it for my class. So for example, the string class is a final. Nobody can do anything modification to the class. So nobody can extend the string class. Remember, if you do extend, you can potentially write some methods for the subclass. But if I define the class as a final, nobody can extend it. Nobody can have a subclass for this. So if I have a method, for example, in this case is checking the password. I don't want anybody to overwrite this method and change it to whatever they want to do. So I'm writing this method in my super, and I don't want anybody to change it. So I'm going to put the word final before it. That's going to tell if anybody create a subclass of this class and they try to override this method, it's not going to let them do. They don't have a permission to override this method. This method has to be used the way it is, and nobody can override it. That's what the final is.